Hey guys, welcome to my channel. So today's our Leetcode Weekly Contest 415 second problem is maximum multiplication score. Okay. So basically we are given an integer array A of size 4 and another integer array B of size at least 4. And you need to choose four indexes I0, I1, I2 and I3 from the array B such that they are in ascending order, that is I0 is less than I1 and so on. Okay, and your score will be equal to the value of A of 0 into B of I of 0 plus A of 1 into B of I of 1 plus in this way. Okay, and you have to basically return the maximum score you can achieve. B vector is given and A vector only contains four values and B vector contains four or more than four values. So you have to choose four values from this B vector in such a way that once you perform this particular operation on those values, you get the maximum score. Okay. So suppose in this example, if we choose this 0, 1, 2 and 5 indices from B vector, then we get the result 3 into 2 plus 2 into minus plus 5 into 4 plus 6 into 2. Okay, that is equivalent to 26. So 26 is basically the maximum value that we can get on performing this operation on any of these four values that we can choose from this B vector. Okay, hope you have understood this problem. So what we can do to solve this particular problem, the first approach that comes into our mind is brute force, that we will find all the possible ways in the all the possible ways we can find the this four element from this vector. Okay, and I will perform this operation on each of those ways, and I will take some maximum variable where I will store the maximum answer. Like whenever I receive new answer, I will compare it with the maximum answer that I have received earlier, and at the end I will return that maximum answer. Okay, so what does the code look like for this solution? Okay, so here as you can see, this is the given function. Okay, I have done this recursion call on like I have done this recursion function where I passed a, b, 0 and 0. So 0 is currently this a index pointing to this like suppose here it's a index and b index. So a index is pointing to 0th index of a vector and b index is pointing to 0th index of b vector. Okay, now for recursion we have to write edge cases. Okay, so the first edge case would be if this index goes to the fourth index. Okay, that is we are starting from 0, so if it becomes equal to the array size a size, that is 4 or greater than 4, okay, then I will return 0. And the second is suppose b is 7, so if b of index is greater than or equal to b of size, that is it becomes 7 or greater than or equal to 7, then I will return int min. Okay, why I am returning int min? Because see in the constraints it is given the minimum value can be 10 to the power 5. So there is possible that all the values are in the vector are negative. Okay, so we can receive the negative value. That's why instead of 0 or -1, I am taking this int min. Okay, you can choose any value less than 10 to the power 5. Okay, now basically what I can do on any index of a of this a vector and b vector, I can take it or I cannot take it. Okay, so if I perform this take operation, then what I will do is, suppose I am here, that is 0 and 0 are pointing to here. Okay, so if I take these two values, then what I will do is I will simply multiply these two values, that is 3 into 2. Okay, plus then basically I will perform this recursion call, okay, on a of index plus 1 and b of index plus 1. Okay, so I perform this operation on this particular three values, so I will move to this index 1, okay, containing two value. Okay, and if I do not take this, see, I definitely have to take this particular index, okay, because there are four values only, but here I can choose whether I have to take this or not. So if I don't want to take this to value, then what can I do is I can simply use this recursion call where I will take the a of I will just pass a index as it is, okay, that is 0 value only, but I will increment my b index by 1. So from 0 now it will become 1, okay, in this way. So if I so this take will basically receive the maximum answer that it can get by taking this 3 and 2 values, and this non-take will give the maximum answer that this recursion can get by not taking this 3 and 2 values. Okay, so maybe it would take 3 and minus 6, 3 and 4. So in this way it will go. Okay, and at the end the maximum we will return the maximum value of take and non-take. Okay, so let me just show you the dry. Let me just dry run one time so that you could understand it better way. So suppose I like A index is 0 and B index is 0. Okay, I am here. Okay, now for the take, what we will do if I take it, so 3 into 2 would be 6. Okay, so 3 into 2 will be 6, and then I will make the recursion call on this 2 and this minus 6. Okay, so again this recursion will happen, and again we will take it. So I will take 2 and minus 6, then again the recursion call will happen. Okay, and this now the recursion would be at 5 and 4. So again the operation take operation will perform 5 into 4 plus recursion on 6 and minus 5. Okay, then again this on this particular recursion 6 into minus 5 plus the recursion on a of index plus 1, that is a index has become 4 now. So now when it becomes 4, then this condition will work and it will return 0. So 0 will return here. Okay, and the take will contain the value of 6 and minus 6 into minus 5, that is minus 30, and then non-take will work. Okay, so non-take means we are not taking this minus 5, instead we are taking this maybe we are taking this minus 3. Okay, so A index is same, but B index is minus 3. Now we will perform this take and non-take on this particular 6 and minus 3. Okay, in this way. And at the end, what I will get the maximum result from this non-take. Okay, so take will contain minus 30 and non-take will contain the maximum answer that it will get after this 3 and performing this operations on like 6 and minus 3, 6 minus 2, 6 minus 7, etc. Okay, and at the end it will return it. So right, it will work in this particular way. So the coming to the time complexity of this particular solution is we are applying recursion. Okay, and at each recursive call we are like performing two operations, take and non-take. So and these operations are basically performed on this b dot size. Okay, n times. Okay, so the total time complexity would be 2 to the power n. Okay, now if I run it, yes, it is running fine. Okay, but the time complexity is too long, so it will definitely give TLE. So what we can do to reduce the time complexity, we can use the approach memoization. Okay, so in the memoization, basically we will use this 2D DP. Okay, and what I will do is whenever I visit some this particular index, that is DP of A index and B index. Okay, then if I visit it, then I will simply mark it by DP of A index and B index is equal to this particular thing, that is max of take and non-take. Okay, and if I visit this particular index again, and if it is marked, then instead of again performing recursion on this index, I will simply return the value that is stored in the DP. Okay, so let me just write it code. So vector of long int. Okay, so long int. Oh my G alphabet is not working. Okay, a long int. Okay, and the name of this 2D vector would be DP, and okay, data size, and then we will again take this vector of long type. Okay, and what is the size of what are the number of columns in this DP vector? It will be equivalent to b dot size. Okay, so b dot size. Okay, and initially all the values in this DP vector will be int of main. Why I'm taking this int of main? Because in the constraint it is given that the value can be negative 10 to the power minus 5. That's why I'm taking the number that is less than 10 to the power minus 5. Okay, so now I have to pass this to DP in our recursive function. Okay, and I have to also pass this 2D vector, that is DP, in here. Okay, and I will pass it by reference. Okay, and I have to again in this these recursion also I have to pass DP. Okay, and see what if like I have to, if I perform some operation of on A index and B index, then I have to check it, basically mark it into this A of DP, this DP. Okay, so A of DP of A of index and B index. B index is equal to max of take and non-take. Okay, now our DP will be storing this particular uh, the answer that we received at this particular indexes. Okay, and similarly I have to perform this check at each and every recursion that in the DP the following A of index and B of index are visited or not. Okay, so if it is not equal to intermin, that means we have visited this A of and B of index. Okay, then what I will simply do is I will simply return DP of index and B index. Okay, I forward this semicolon. Okay, I think this should work now. Yes, it is running fine. And now if I submit it, yes, it is accepted. So hope you have understood this problem, guys. If you like this video, give me a thumbs up and subscribe to the channel. Okay. See you in the next video. Till then, goodbye.